In this video, we are going to discuss neutralization and titration. And neutralization is what happens when we mix an acid and a base. And titration is a type of reaction that does a neutralization. And it's where we're going to use this tube, this glass tube that's called a burette, to add one solution and figure out how to use it to figure out the concentration of an unknown solution. And that's a titration. So an acid-base reaction, where you mix them together, is called a neutralization reaction. The products of an acid and a base are water and a salt. And remember, the salt is some sort of ionic compound. Note that acid and base reactions, we've actually already seen these. They are double replacement reactions, where one of the products is water. So we are going to do double replacement reactions. Sit down and shut off the video and try to predict the products and balance the equations here. Again, double replacement would mean that the cations would swap with each other. So the hydrogen, H+, is going to end up with the OH-, and that's going to make water. And then the potassium is going to end up with a bromide to make KBr. So pause, fill in the reactions, and then restart the video and see how you did. So notice in here I color-coded it, so the red is hydrogen plus the OH, that makes water. The blue is K plus Br to make KBr, and it is already balanced, so there's no balancing left to do here. So again, hydrogen and hydroxide are going to come together to make water, and then lithium and chloride are going to make lithium chloride salt. So again, on the next page, for the rest of the reactions, pause the video, fill them in, and then turn it back on to see how you did. Okay, so just a couple things to talk about here. The first two that we did, everything was balanced already, but this is a little bit more complicated. When the barium gets together with the fluoride, make sure that the formula is correct. Barium is +2, so it's going to be BaF2 to make a correct formula. And it's going to make 2 waters, and then we need a 2 over here to balance the HF. So again, here we're going to need a 2 to balance the lithium hydroxide. Make sure that your formulas are correct before you try to balance your reactions. Phosphoric acid is triprotic, so it's going to have 3 protons, and it's going to need 3 hydroxides to balance it. So we put a 3 here, we make 3 waters, and then we make sodium phosphate. So check the rest, and ask your teacher if you have any questions and if you can't figure any of them out. Okay, so a titration is when we set up a reaction so that we can do a test to figure out one concentration by adding another acid or base of known concentration. So the equation that we use for titrations is written up here, and it is mass of the molarity of the acid, so the concentration of the acid, times the volume of the acid, times the number of protons in the acid. So if it's monoprotic, it's 1 proton, diprotic, etc. Equals the molarity of the base times the volume of the base times the number of hydroxides in the base. All of these bases are going to be hydroxide bases. The volume is in milliliters, and the molarity is moles per liter. So the equivalence point is what happens when we reach the equalization, where the number of protons is equal to the number of hydroxides. And that's what we're aiming for in a titration, where everything is going to be balanced. Because what we do is we add what's called an indicator. And what an indicator is a solution that changes color with pH. So we will use phenolphthalein, which is clear below pH 7, and then when the pH gets above 7, so we reach the equivalence point, it turns pink, and we want to stop when it's really, really faintly pink. So that tells us when everything is equal. That's the end point. So the rest of this video is going to be practice writing equations and doing titration calculations. So I didn't rewrite the equation, but it's the equation, the titration equation that is in your notes. So in this reaction, we have HCl, and we know the volume, and it is mixed with 43.7 milliliters of sodium hydroxide, where we know the concentration of the sodium hydroxide, and we are going to use that to figure out the concentration of the unknown HCl. So here's the balance equation. HCl plus sodium hydroxide gives water and sodium chloride. The number of protons and the number of hydroxide is both 1, so it's pretty straightforward. And then we're going to set up our titration equation, and we are going to calculate Ma, so the molarity of the unknown acid. Okay, again, you might want to pause the video and try to set it up, and then turn it back on and check your notes. It is really useful to make a list like we did when we did gases. So as you read the problem, make a list of the information that you know in the problem. We know the volume of acid. We're looking for its molarity. We know the number of protons. We have the volume of the base. We have its molarity, and we know the number of hydroxides. So we have everything that we need to solve for Ma, or the molarity of the acid. So we set up our equation, and then we solve for our unknown Ma. So it's going to be 0.13 times 43.7 times 1, take that answer, and then divide it by 26.9, divide by 1. And don't forget that the concentration is always going to be in molarity, which is capital M. Okay, so we're going to do the next one. Pause the video, write out the reaction, see how you did, do the calculations, set up your equation, and make a list. Use your equation and solve for the concentration of the unknown acid, and then turn the video back on and see how you did. So in this reaction, it is acetic acid plus sodium hydroxide, and that's going to make water and sodium acetate. Again, 1 proton, 1 hydroxide, so it is a pretty simple equation. Don't have to do anything to balance. So the information that we have in our problem, we're given the volume of the acid. We're going to look for the concentration of the acid. That's our unknown. 1 proton, volume of base is given, molarity of the base is given, and we have 1 hydroxide. So again, just set it up with a titration equation and then solve for our unknown acid. So the molarity here is 0.413 molar. So in the next reaction, it is lithium hydroxide plus sulfuric acid, again to give water, lithium sulfate. Here we had to do some balancing, make sure that the formulas are correct, and we need a 2 here to balance and a 2 with the water. And here the acid has 2 protons, so we're going to use that in our equation. So here we're going to calculate the concentration of the base. The concentration of the acid is known, and we're going to look for the base. So again, make a list. Molarity of the base is our unknown. We have its volume. We have 1 hydroxide in the formula. Molarity of the acid is given. We have its volume. And because it's sulfuric acid, it's H2SO4, it's going to have 2 protons. So this is going to be a 2. And use the same equation and set up and solve for the unknown molarity of the base. and it is 0.448 molar. Last reaction, HCl plus magnesium hydroxide giving water and magnesium chloride. Again, pause the video, go through, make a list, figure out the problem, and then check your answer. Here's a list. We're going to be looking for the molarity of the acid. We've got 1 proton, 2 hydroxides in our base. So the molarity of the acid is 0.342 molar. The end.